The universe has a rule, a fundamental law older than stars, harder than steel, absolute as mathematics itself. Entropy must increase. Everything must become more disordered. Energy must spread. Structure must decay. The universe is moving toward chaos. Not slowly, not eventually. Always. Right now. This is not philosophy. This is physics. The second law of thermodynamics. One of the most tested, most confirmed principles in all of science. And yet, when you look up at the night sky, you see the opposite. Galaxies arranged in vast cosmic webs, stars burning with precise nuclear reactions, atoms holding stable configurations, molecules assembling into intricate chains. Life. All of this is order. Complex, improbable, beautiful order. So here's the question that physics cannot avoid. If the universe must become more chaotic, why is it structured? One of these things must be wrong. Either our understanding of entropy is incomplete, or the structures we observe should not exist. We're going to resolve this paradox. But the answer will not be what you expect. Let's start with what entropy actually means. Most people think of entropy as disorder. That's not wrong, but it's incomplete. Entropy is a measure of how many ways a system can be arranged while still looking the same. The more ways, the higher the entropy. Imagine a deck of cards. If the cards are sorted by suit and rank, there's only one arrangement that satisfies that description: low entropy. But if you shuffle the deck randomly, there are billions of arrangements that all look equally random. High entropy. The second law says systems naturally move toward states with more possible arrangements, toward higher entropy. A hot cup of coffee cools because there are vastly more ways for thermal energy to spread through the room than to stay concentrated in the cup. A glass shatters because there are more ways for the fragments to scatter than to hold together. This is not just tendency. It is statistical inevitability. So when we see a galaxy, billions of stars arranged in spiral arms, orbiting a common center, we are seeing something that should not spontaneously form. There are far more ways for that matter to be scattered randomly through space. Yet galaxies exist, and that demands an explanation. Here is the key insight, and it changes everything. The second law does not say entropy increases everywhere. It says entropy increases in total, for the entire universe, for closed systems, for the complete accounting of energy and disorder. But locally, in a specific region, order can increase, structure can form, complexity can emerge, as long as the total entropy elsewhere increases by more. Think of a refrigerator. Inside, the air cools, molecules slow down, their motion becomes more organized. Entropy decreases inside the refrigerator. But the refrigerator doesn't violate thermodynamics. It runs on electricity. That electricity came from a power plant burning fuel. That combustion produced heat, exhaust, disorder. The total entropy of the system, refrigerator plus power plant plus atmosphere, increased. The refrigerator creates local order by producing greater global disorder. This is not a trick. This is how order forms in the universe. But there's something more fundamental at work. Order doesn't just require entropy increase somewhere else. It requires something specific, something dynamic, energy flow. When energy flows through a system, moving from high concentration to low, it can leave structure in its wake. A candle flame is a perfect example. The flame has order. Heat rises in organized currents. Chemical reactions proceed in predictable cycles. Wax vaporizes, combusts, releases energy, and the pattern repeats. This structure is not static. It's not a frozen arrangement. It's a dynamic pattern sustained by energy flowing from chemical bonds in the wax to thermal radiation in the air. As long as energy flows, the pattern persists. The moment the energy flow stops, when the wax runs out, the flame disappears. This kind of order is called a dissipative structure. It exists because of energy flow, not despite it. And this is the key to understanding the universe. Almost every ordered structure in the cosmos is a dissipative structure, maintained not by resisting thermodynamics, but by channeling energy flow. Stars are the most dramatic example. A star begins as a cloud of gas, diffuse, spread across light years, high entropy in its distribution. But gravity pulls inward. As the cloud contracts, gravitational potential energy converts to kinetic energy. The gas heats up. Pressure builds. Eventually, the core becomes hot enough for nuclear fusion to ignite. Hydrogen nuclei collide and merge into helium. Mass converts to energy. Light and heat radiate outward. This outward pressure balances the inward pull of gravity. The star stabilizes, and for millions or billions of years, it burns. A sphere of plasma, held in equilibrium, fusing elements in its core, radiating energy into space. That radiation is key. Every photon the star emits carries entropy into the universe. The star creates local order, a stable, structured object, by producing enormous amounts of disorder in the space around it. The star doesn't violate the second law, it fulfills it. The total entropy of the universe increases. But within the flow of energy from core to surface to space, structure emerges. This is not unique to stars. This is universal. Let's shift scale, down to chemistry, down to molecules. On Earth, life depends on energy flow. The sun radiates light. Plants capture that light through photosynthesis. They use it to convert carbon dioxide and water into glucose. Glucose stores chemical energy. Animals eat plants. They break down glucose. They extract energy. They build proteins, cells, tissues. At every step, structure forms. Complexity increases. Entropy decreases locally. But the sun is burning, fusing hydrogen into helium, radiating energy into the cold vacuum of space. The entropy increase from solar fusion vastly exceeds the entropy decrease in every living organism on Earth. Life is not an exception to thermodynamics. It is a consequence of thermodynamics. Now consider this. The same process happens in space. In the dark molecular clouds between stars, where temperatures hover near absolute zero, chemistry occurs. Atoms drift through near vacuum until they encounter a dust grain. They stick to its surface. They slide slowly across ice. Over thousands or millions of years, they meet other atoms. Water forms, ammonia, methanol, even complex organic molecules. This is chemistry without warmth, without pressure, without the conditions we thought were necessary. But it follows the same principle. Energy flows through these clouds. Starlight, cosmic rays, gravitational heating. Wherever energy flows, structure can emerge. Now we go further back, to the beginning. 13.8 billion years ago, the universe was born, not as structure, as chaos. A hot, dense plasma. No atoms, no molecules, not even atomic nuclei. Just a soup of fundamental particles, colliding at enormous energies. Entropy was incredibly high, not in the sense of disorder, but in the sense of possibilities. Nearly infinite configurations, all equivalent. Then the universe began expanding, and as it expanded, it cooled. Within the first few minutes, the temperature dropped enough for protons and neutrons to bind. The first atomic nuclei formed, hydrogen, helium, traces of lithium. 380,000 years later, the universe cooled further. Electrons could now bind to nuclei without being immediately knocked free by radiation. The first atoms formed, and with them, something remarkable happened. The universe became transparent. Photons could travel freely. The cosmic microwave background radiation, the afterglow of the Big Bang, was released. But the universe was not uniform. There were tiny density fluctuations, quantum irregularities from the earliest moments, stretched to cosmic scales by inflation. Gravity amplified these fluctuations. Denser regions attracted more matter. They grew denser still. Over hundreds of millions of years, these regions collapsed. The first stars ignited. The first galaxies took shape. This wasn't random. This was structure formation driven by gravity, expansion, and energy flow. All of it consistent with thermodynamics. All of it increasing total entropy, but producing staggering local order. There's something profound here. The early universe was smooth, homogeneous, high entropy in one sense. Everything was the same. But low entropy in another sense. All that energy was concentrated in a small, hot, dense state. As the universe expanded and cooled, entropy increased. Energy spread. Space grew. And within that expansion, pockets of order emerged. Not despite entropy increase, because of it. Gravity converts potential energy into kinetic energy, then into thermal energy, then into radiation. At every step, entropy rises, but structure forms along the way. The cosmic web of galaxies, the stars within those galaxies, the planets orbiting those stars, the chemistry on those planets. All of it a consequence of energy flowing from high-density regions to low-density space. Order emerges wherever there is flow, but order has limits. Inside a star, temperatures climb so high that molecules cannot exist. Atoms themselves ionize. Electrons are stripped away. Only plasma remains. Classical chemistry doesn't operate here. Chemical bonds require electrons to be shared between atoms. In plasma, there are no bound electrons. This is not the destruction of order. It's a different kind of order. Plasma follows its own dynamics, magnetic fields, fusion reactions, quantum processes. And when conditions change, when a supernova explodes and the gas expands and cools, atoms reform. Electrons recombine with nuclei. Chemistry returns. The universe doesn't erase order. It transforms it. At extreme temperatures, matter exists as plasma. At moderate temperatures, as atoms and molecules. At low temperatures, as condensed matter. Solids, liquids. Each regime has its own structures, its own rules, its own emergent complexity. But all of them obey thermodynamics. So let's return to the original question. Can the universe create order by itself? Yes, absolutely, undeniably, but not by violating the laws of physics. By following them, order is not forbidden by thermodynamics. It is enabled by thermodynamics. When energy flows through a system far from equilibrium, structure can emerge. Patterns can form. Complexity can increase. Locally, while globally, entropy still rises. The refrigerator, the candle flame, the star, the living cell, the molecular cloud, the galaxy. All of them are dissipative structures, temporary islands of order in a universe moving toward equilibrium. Temporary, but real. Temporary, but significant. We exist because energy flows, because the universe is not in equilibrium, because there is a gradient from high energy states to low energy states, and we live in the middle of that flow. Here's the final insight. Chaos and order are not opposites. They are not in conflict. They are two aspects of the same process. The second law of thermodynamics does not prevent order. It explains order. Entropy increase is not the enemy of structure. It is the engine of structure. Without entropy gradients, there would be no energy flow. Without energy flow, there would be no stars, no chemistry, no planets, no life. The universe does not create order despite chaos. It creates order through chaos. And perhaps that is the most beautiful truth in all of physics. The galaxies you see, the atoms in your body, the thoughts in your mind. All of them are expressions of the same principle. Energy flowing from order to disorder, leaving complexity in its wake. The universe is not fighting entropy. It is surfing it. And in that motion, everything becomes possible.